Today we're going to talk about geometric proofs. The other day we talked about algebraic proofs and we used our properties of equality. Today we're going to talk about geometric proofs where we use properties of congruence. So the first definition is a theorem. So what a theorem is, it's a statement that can be proven true. And we've already talked about a couple of theorems earlier in the year, like the Pythagorean theorem. A postulate is a statement that is accepted as true without proof. And we've had some of these this year already, like the segment addition postulate, where we had one segment plus another segment would equal the whole thing, where it's kind of like, duh, that makes sense, but there's no proof for that. So it's a postulate, we just assume that to be true. And then a definition, the formal definition of definition is a statement that is true in if-then form and converse forms. So if we have a statement that is true and the converse is also true, then that is a definition. So now let's talk about some of the congruence theorems for segments. We have the reflexive property of congruence, where a segment is congruent to itself. And then we have the transitive one, where if A is congruent to, or if AB is congruent to CD, and CD is congruent to EF, then we can cut out that middleman here. This is our middleman, and just say that segment AB is congruent to segment EF. And the same is true about angles. So if we have an angle A, then angle A is congruent to angle A. Notice how we're using congruent symbols and not equal signs. So that's why I don't have any M in front of these angles for measurement. And then again, for transitive, if angle A is congruent to angle B and angle B is congruent to angle C, then angle B here is that middleman. So then angle A is congruent to angle C. And we're going to be using these properties today. So we're going to identify the properties shown. Angle 3 is congruent to angle 3. Well, that is an angle congruent to itself. So that is the reflexive property of congruence. And then if angle H is congruent to angle T, and angle T is congruent to angle B, then angle H is congruent to angle B. So angle T here is our middleman. So this is the transitive property of congruence, and we're going to abbreviate this. POC. Just like how for property of equality, we said POE, we're going to do POC for property of congruence. Now this one, segment CD is congruent to segment DC. Remember, when you're naming segments, the order doesn't matter. Segment CD is the same as segment DC. So this is the reflexive property of congruence. And then the last one, we have segment DB is congruent to segment ST, and we have segment ST congruent to segment GH. So here's our middleman here, segment ST. So this is the transitive property of congruence again. So on the next page is the format on how we write two-column proofs. And we kind of started this with our algebraic proofs where we broke it up into columns. On the left side, we did an algebraic step, and on the right side, we talked about what that step was. We gave that reasoning for it. So this is the same way where what we're trying to prove is right here, and that's always our last statement, and our given information is up here. So we start with our given information, and then we work towards what we're trying to prove. And we use the postulates, theorems, and properties of congruence or equality that we know to get there. So in this one, we're talking about if AC is equal to AB plus AB, prove that AB is equal to BC. So we're given this right here. Okay, and then what we do is say, well, according to our picture, AB plus BC equals AC. That's our segment addition postulate. We have this part plus this part equals the whole thing. That's what we have written in statement number 2, and we can say that because of the segment addition postulate. Well, then we use the transitive property of equality to get to our next step. So if AB plus BC equals AC, but AC is also equal to AB plus AB, then they're equal to each other. So we took this from statement number 2 and this from statement number 1, and we put them equal to each other. This part went here, and this part went here. And then what they did is they subtracted AB from both sides. So when they subtract AB from both sides, that leaves you with what we were trying to prove. And what we did was the subtraction property of equality. We subtracted both sides by AB. So this does take time to practice and get good at, and you're writing out every single small step you're making and giving a reason for it. So let's look at some examples down here. Here's our bank up here for reasons, and we're going to put those reasons in our proof so that the proof follows the correct order to prove the statement we're trying to make. So we are given that ray BD bisects angle ABC. We are given that. Okay, so that is our first statement right here. And the reason why we can say that is because it is given. Okay. Now, statement number 2 says angle 1 is equal to angle 2. Well, why can I say that? Why can I say that angle 1 is equal to angle 2? Well, remember, if that's the definition of an angle bisector. It cuts an angle into two congruent angles. So we look at this statement right here. If a ray bisects an angle, then it divides an angle into two congruent segments. That's the definition of an angle bisector. So this is our statement number 2. If a ray bisects an angle, then we have two congruent angles. Okay, so then statement number 3 says that the measure of angle 1 is equal to the measure of angle 2. And this may be a step that you think is kind of trivial to do, but we have to go from congruence now to equality. In statement number 2, we had a congruent sign, and in statement number 3, we have an equal sign. So that statement is going to be this one right here. If two angles are congruent, then they are equal in measure. So if we have congruent angles, then they are equal measure. And then statement number 4, okay, so we have the measure of angle ABC equals the measure of angle 1 plus the measure of angle 2. Well, that's the angle addition postulate. If I have this whole angle here, and I add angles 1 and 2, that equals the whole thing. So that is going to be the angle addition postulate. And then the measure of angle ABC equals the measure of angle 1 plus the measure of angle 1. So what we did here is we substituted the measure of angle 2 with the measure of angle 1 because statement number 3 says that those two are equal. So we used what we proved in statement number 3 and statement number 4 to get our fifth statement, and we substituted. So this is going to be the substitution POE. And then if we have the measure of angle 1 plus the measure of angle 1, that's 2 times the measure of angle 1. And that is combining like terms. So one of the reasons why this can be difficult is that you have to remember what all these definitions are. You have to remember what an angle bisector is. You have to know what the angle addition postulate is. You have to know combining like terms. You have to know what all those things are and use them in your proof. All right, let's look at the next page. What we're going to do here is we're going to prove that M is the midpoint of segment RB, and we're given that R is the midpoint of AM, and we're also given that MB equals AR. So I'm going to mark up this picture a little bit just to kind of help us out here. If R is the midpoint of AM, that means AR and RM are congruent because that's what a midpoint is. And if MB and AR are congruent, okay, and that one, so they all have one tick mark. So now what we just have to do is formalize this proof and go through it. So the first thing is that R is the midpoint of AM and MB equals AR. That is given to us. AR is congruent to RM. Well, that's the definition of a midpoint. Okay, if the point is a midpoint, then the segments are two congruent parts. If R is this midpoint, then we get two congruent segments. So the reason why we can say those two segments are congruent is because it is a midpoint. If a point is a midpoint, then it divides a segment into two congruent parts. And then we say the length of AR is equal to the length of RM. Well, if the segments are congruent, like we proved in statement 2, then that means they have equal measurements. So this one right here, if segments are congruent, then they are equal in length. That's the one we want. We don't want this one down here, if segments are equal length and they are congruent. We don't want that one because all we've established is that AR is congruent to RM. We're going to use that information, that's what this if part is, to then say those segments are equal length. So statement number 3, let me use a different color here. Statement number 3 is going to be if segments are congruent, then they are equal in length. Okay. So now in the next step, instead of AR equals RM, we have MB equals RM. Well, what we did is back in our given information up here, we were given that MB is equal to AR. The length of a segment MB is equal to the length of AR. So what we're doing is we're doing some substitution. We're taking AR out and plugging in MB. So this is the substitution property of equality. Okay, so now that they have equal measures, we know that they are congruent. Okay, we use substitution. So now we're going to use this statement here. If two segments are equal in length, then they are congruent. Because in statement 4, we said those two segments are equal. And now we're going to say that they are congruent. So if segments are equal, then they are congruent. And then if those two segments are congruent, okay, so segments MB and RM, MB and RM, if those two segments are congruent, then that means M must be a midpoint. So you notice how I phrase it. I said, if these two segments are congruent, then M is a midpoint. So we want to use this statement up here. If a point divides a segment into two congruent parts, then the point is a midpoint. So you got to be very careful with how you are phrasing this, because we had the converse of that right here, and we use that in reason number 2. So if two segments are congruent, then it has a midpoint. Okay, so that is how we could say that statement number 6 is true. So I know that this can be confusing. This is another one of those things that more practice will make you better at it, but you really need to be thinking about every single step that you're doing, and that's how you're going to get better. So thank you for watching. Make sure you like the video and subscribe.